Hello, today's topic is position of roots in a quadratic equation. Okay, so first we introduce this concept, then we go further for different conditions. Let fx is equals to ax squared plus bx plus c, a quadratic equation with real coefficients and with real coefficients and k comma k1 comma k2 be real numbers such that k1 is less than k2. Now let alpha and beta be the roots of the equation. Then alpha is equals to minus b minus root over d by 2a, and beta is equals to minus b plus root over d by 2a, where d is equals to the discriminant. Okay, now came to the first condition, that when a number lies between the roots. Okay, if a number k lies between the roots of a quadratic equation fx, then the equation must have real roots and the sign of fk is opposite to the sign of a. If a number k lies between the roots of a quadratic equation fx equals to 0, then the equation must have real roots and the sign of fk is opposite to the sign of a, as is evident from the below picture, which I am going to draw. So this is the two axes, this is y and this is x, and this is our curve, which is y equals to ax squared plus bx plus c, which is evidently a parabola. And this is alpha, this is beta, and here we get k, and this is f of k. Okay, now the next picture is looks like this. Here a must be positive, here a must be negative. This is fk, and this is k, this is alpha, and this is beta, and y equals to x squared plus bx plus c is the equation of the curve. Thus a number k lies between the roots of a quadratic equation if d is greater than 0 and a if k is less than 0. Okay, now we try to illustrate this with an example. The values of a for which the equation 2x square minus 2 into 2a plus 1 x plus a into a plus 1 is equals to 0. We need to find the values of a for which the equation may have one root less than a. We need to find the value of a for which this equation may have one root less than a and one root greater than a. Okay, so let's start the solution. Let me take it here another color. The given condition suggests that a lies between the roots. Okay, and let fx is equals to 2x square minus 2 into 2a plus 1 x plus a into a plus 1 equals to 0. Okay, clearly coefficient of x square is positive here. Clearly coefficient of x square is positive. Therefore, a lies between the roots if discriminant is positive and f of a is negative. Now, discriminant is equals to 4 into 2a plus 1 square minus 8a into a plus 1 for this equation, and after solving this we get 8 into a square plus a plus half, which is greater than 0, which is true for all a, true for all a belongs to R. Okay, and as f of a is less than 0, then we can write that 2a square minus 2a into a plus 1 plus a into a plus 1 is less than 0. Therefore, minus a square minus a is less than 0, and this implies a square plus a is greater than 0. So a must be greater than 0 or less than minus 1. So our required answer is this, that is, whenever a is greater than 0 and less than minus 1, the equation may have one root less than a and other root greater than a. So that's all for today. Thank you very much.